Hello guys, good afternoon. My name is Mohammed Awad Sheikh Bashaib. I'm a student at Istanbul Aydın University at the Department of Computer Engineering, and today I will be representing my final engineering project 2. My project topic is about face mask detection with Java as the programming language. Now, before we start with this project, let's take a look about the contents in it. At first, I will talk about the system overview of the face mask detection, and second, I will talk about the system characteristics. Then I will talk about the system architecture. Then we will go to the system implementation. Now, for more information, the system implementation, we will take a brief look on the code blocks in the implementation, and we will talk about them and explain what the code blocks do for this project. In this project, I will talk about an Android application to detect face mask in Android smartphones using Android Studio as a platform and Java as my language code. The emphasis of this project here is to detect face mask in smartphones application. Face mask detection usually uses artificial network to recognize if a user is not wearing a mask, and the application can also be connected to any existing or new IP mask detection cameras to detect people without a mask. System overview. The face mask detection consists of two parts, the user and the system. When using this project, the face mask detection, as we said before, uses an artificial network to identify if a user is not wearing a mask. The Android application can be connected to an Android existing phone camera to detect people without a mask. If the data obtained from the camera view shows that the person is wearing a mask, it will show a green square. But if the camera captured unrecognized person not wearing a mask, alerts may be sent with the picture of the person, which will enforce them to wear a mask. This project can also make the Android application user to add faces and phone numbers to send them an alert when not wearing a mask if it's in the right hand. As shown in the figure below, there are two steps that need to happen in order to run the face mask detector. Now, as you can see in step 1, it detects faces in the image, the image are taken from the input frame, and it will be detected by face detector. For each detected face, we will run the face mask detector, which will give us a result of no mask or mask, as you see in step number 2. The system characteristics. For the face mask detection project to work, the system depends on you, the user, and Java, which is the required development language. In order to create the face mask detector, a deep neural network will be trained, which is capable of distinguishing between masked faces and unmasked faces. Now, the characteristics for this project are image datasets need to be built to include masked faces file and unmasked faces file. Implementation of neural network need to occur, which is capable of helping the face mask detector. Neural network will come into play while the model is being trained. Training the face mask detector. A Java and OpenCV will be created, which means that a program will be opened and the laptop will run the camera. Then it will compare real faces and pictures taken from smartphone or from the dataset. Finally, a result is given on the screen, which is a subset of my dataset and will appear as a rectangle frame on their faces. The system architecture shows two steps. In the first step, the face mask detector is being trained by loading the face mask dataset, and then the face mask will be classified with TensorFlow. After the dataset is trained, it will be saved. In the second step, we will use the dataset that was saved. Then we will run the face detector, which starts detecting faces and will extract each face. After extracting each face from the trained dataset, we will apply the face detector to determine which faces have mask on it and which are not. You can see an explanation for the system architecture in the figure below. As you can see, in phase 1 or step 1, we train the face mask detector. Then in phase 2, we apply the face mask detector, and it will give us a result of a mask or no mask after applying the face mask detector. System implementation. The system implementation of this project utilizes two-stage detectors. First, a face detector is applied to retrieve the face's position, then each face is cropped and pre-processed to be fed into the second model, which will do a binary classification and will detect between mask or no mask. Now, for you to fully understand, we will take a look about the implementation code for this project, and we'll briefly explain the code blocks of this project. As I told you moments ago, this project is a face mask detection with Java, and it's used on Android smartphones or Android cameras. So for an application, for a project like an Android, I used an Android Studio as a platform for this project to be the platform of my final project. As you can see here, these are two files. First, the detector test, which is used for the first step, which is used for the first step, which is the face detection, which is used for the face detection and the mask detection. And in here, this is the camera activity file, which is used for the camera. Of course, when we open the laptop camera, this file has all its implementation. So in this file, for the face detection step, it consists of 4 bitmaps. First, the RGB frame bitmap, the cropped bitmap. RGB frame bitmap is used where the preview frame is copied. The cropped bitmap is used to feed the interference mode, and the portrait bitmap is used to rotate the input frame in a portrait mode for devices that have the sensor in landscape orientation. And last but not least, the face bitmap, which is used to draw every detected face, cropping its detected location and rescaling it to 224 pixels to be used as an input for the mobile models. Now, as you can see here, this is the cropped bitmap. In the cropped bitmap, the face detection is done on it. Since it is smaller, it can speed up the detection process. If faces are detected, the original frame will be drawn in the portrait bitmap for us to proceed with the second step detection. Now, for each detected faces, it's the bounding box. The bounding box here, the bounding box will be retrieved and mapped from the cropped bitmap, which will replace the original space. This way we can get a better resolution image to feed the mask detector. So we can say the match bounding box it helps us to get a better resolution for that to feed the mask detector. Now in here, this line code will load the images from the data set, and each image which is loaded from the dataset will be run by a face detector. Now for each detected face, a face mask detector will run on it to check if the face, if it's masked or unmasked. How it will be run? By loading the recognition. After loading the recognition, the faces that were saved inside the load image inside the data sets, it will be recognized by the mask detector to give us the result of mask or no mask. After the mask detector takes place, the face cropping is done by translating the portrait bitmap to the face's origin and scaling in such a way that the bounding box here size matches the 224 pixels that we showed you moments ago. And finally, we can run this detector test after the bounding box matches the 224 pixels, and will show us the output. In the camera activity file, This file it's specially used for the camera. Like for example, when you open the laptop camera, this file, the preview of the width of the face that is shown in the camera is used in here. Like how much is the width, how much is the height, and the processing frame, and the RGB bytes is also used in this file here, as we can see. And the image converter, which converts the picture from one person to another. It's all used in this camera activity file. Now let's take a look to what will happen when we run this project, and to check if the output if the application is really working or not. Since this project is only working on Android application mobiles, I took a snapshot when I tested the system on an Android device, and here's what I got. As you can see in the picture in front of you, it is me not wearing a mask and testing the system, which gave me a result of 100% no mask with a red frame surrounding my face. And in here I tested the application by not fully wearing a mask, which gave me a result of by not fully wearing a mask, like not covering my face and nose, which gave me a result of 99.85% no mask with a red frame surrounding my face. In here I tested the application by wearing the mask in the right way, which is covering my nose and mouth, and it gave me a result of 100% mask with a green frame surrounding my face. After successfully testing the system, it's my time to thank you for your time and efforts. This is the end of my project. Thank you so much. Hope to see you in better days.